All right, so very simply, a rational expression is a ratio, or ratio, of two polynomials. Ratio of two polynomials. Excluded values, for vocab purposes, a value that makes the denominator equal to 0. So we can't have it. Alright? Whether this is good news or bad news, this is going to involve a boatload of factoring. Alright? And then what you're going to look for is polynomials that cancel each other out. Alright? And that's how we simplify. So, 3x minus 12. Does 3 go into 12? Yep. So I'm going to pull out the 3. That's going to give me x minus 4. Then x squared minus 16 is the difference of two squares. So that's going to factor in x plus 4, x minus 4. Now, before you start simplifying, alright, that's when you start figuring out your excluded values. And that you're welcome. Those are going to be the same thing as zeros or solutions. So in other words, what's the opposite of plus 4? Negative 4. What's the opposite of negative 4? 4. So when you do excluded values, you simply put x not equal to. Alright, if you want to write them separately, it would be negative 4 and 4. If you want to write them together as a plus minus 4, go ahead. Now, what do the x minus 4s do to each other? Cancel out. Leaving you with a sole denominator of 3. Alright? And a sole denominator of x plus 4. Alright? And then the operations we're going to do today are multiplying and dividing. We're going to factor as much as possible. We are going to factor as much as possible. And then we're going to cancel any polynomials found in both the numerator and denominator. All right? Now, when we start simplifying, I'm going to leave the first one alone for the time being. And then I'm going to factor the one on the right. What two numbers go into 7 add up to 8? What are the only two numbers that go into 7? 7 and 1. So that would factor into a minus 7, a minus 1. Before moving on, is everybody good with that? Factoring where a is equal to 1. Now, if I look at my second denominator, does 6a go into both? Yep. And then that leaves me with a minus 1. What's the opposite of the negative 1? Positive 1. So a cannot be equal to 1. When you have a variable out here, 0 is also an excluded value. Now, what do the 6a's do to each other? Cancel out. What do the a minus 1s do to each other? Cancel out. What's left? The only thing standing in the numerator? A minus 7. What's the only thing left in the denominator? 8. And you're done. So keeping that in mind, work on number 2. Keeping that in mind, work on number 2. Now, first things first. Since I have a 9b there, which is just a variable, b cannot be equal to what? 0. Now, the only reason I factored this out, and we'll come back to it in a second, is to get the other excluded values. The 4b there also gives me 0, so that doesn't help me. But this one now has a coefficient. So you have to remember to divide your constant by the coefficient. In short, you still do the opposite of -1, which is +1, but you bring the coefficient as a denominator, so 1/3. So 0 and 1/3 are the excluded values. Everybody okay with that? Now, I don't need to factor anything besides that, because what are the 12b squared minus 4b going to do to each other? Cancel out. So you don't have to factor them to realize they cancel out. Leaving me with the only thing in my numerators, which is now 10, over my only thing left in my denominator, which is 9b. Alright? Now, division. There's one small change with division. The first term stays exactly the same. 9x squared plus 81x over x squared plus 15x plus 50. The difference is we have to make a small mechanical change. The division is going to become what? Multiplication. And then what are we going to do with our second fraction? Flip it. So that gives me x plus 5 over 1. Alright? Now I'm going to start factoring. Does 9 go into 81? Yep. Do they both have an x? Yep. So that gives me 9x. And then when I'm done factoring out, I got x plus 9. On the bottom, 50 breaks down into 10 and 5. That's x plus 10, x plus 5. Times x plus 5 over 1. What are the x plus 5s going to do to each other? Cancel out. Leaving us with our numerator of 9x times x plus 9 over x plus 10. Notice you're not going to have to do excluded values with division. Because with division it's complicated, because with excluded values then you have to worry about the numerator and the denominator. So therefore we're not going to worry about excluded values with division. If I look at number 5, if I flip the second fraction, I got a plus 10 over a squared plus 7a plus 10 times. We flip it, so now we got a squared plus 7a plus 10 over 1. What do the a squared plus 7a plus 10 do to each other? Cancel out, leaving us with our numerator of a plus 10 and our denominator of 1. You can write it over 1 if you choose, or just leave it as a plus 10. Yeah, absolutely. Alright, so to finish up this lesson, and then you can work independently, take a gander at number 3. Get to work on that one. Number 3. Everybody good with flipping the second fraction? Everybody good with pulling out the 7n to give us n plus 2 as a GCF? What do those n plus 2s then do to each other? Cancel out. Everybody good with pulling the 16n out of the second numerator, leaving us with n minus 2. And then pulling out a 14n squared out of the second one's denominator, also giving us n minus 2. What do the n minus 2s do to each other? Cancel out. Everybody good? Now I got some monomials to work with. 16n over 98n cubed. Alright, go back to your days of laws of exponents, the bigger variables in the denominator. So to avoid negatives, I'm just going to subtract 1. 3 minus 1 is 2, so I got n squared in the denominator. 16 and 98 are both even, so I can cut them in half. Half is 16. 8, half of 98. Boom, you're done.